How you doing? It's Logan. I'm just doing another devlog here. Today what I was working on is rotational springs. I needed this in Godot for something. And yeah, it works pretty well now, but I was doing it last night and I ran into a couple oddities with it as usual. And so I just used this formula, just some physics formula I found. And it's just how you find the torque to apply. So you get X and L are the is the like difference between the rotations of the bodies, or X is the difference between the rotation, and then L is the desired angle that we're trying to get to. And basically it'll just try to make the rotations of these two bodies coincide based on this angle. So we get, okay, what is the difference between the angles now, and then how far away are we from the angle we're trying to get to, and then that'll tell us, I guess, kind of like how much torque we should apply, and then we multiply that by an intensity, and then we subtract the damping times. Damping is like how much you slow it down, as I understand it. Kind of like if I set the damping really low here, I'm not too good with the physics, but it gets more bouncy as the less damping there is, and if you up the damping, it'll kind of get more fixed. So yeah, that works pretty well. When I first implemented those, going crazy. First thing I noticed was Godot normalizes all rotations, whereas this kind of relies on rotations being not normalized. So what normalizes means is it makes all rotations between pi and negative pi. So it has no concept of multiple twists. So like if I were to twist this up like a mouse trap, like spin it around, it actually has no concept of well, that was cool. It has no concept of multiple spins. It's just one single rotation. So initially I was like, that messed me up, and then I just added this little hack right here for that, which I don't need anymore, but that's just the first thing I did when I'm trying to fix it, and that made it work a little bit better. But then I noticed the damping was just all over the place, and actually in a normal physics engine, like damping, like 64, that's pretty high, and like it shouldn't be like too crazy high. Like maybe 100 is like super high damping, but like I actually have it at 400 times 64, so that's like what, like over 20,000 damping. So I think the reason for that, I'm not really super sure, because Godot's documentation on the physics engine isn't super clear, but this applied torque I think may be different than the units of angular velocity or something, or it may be different or something, but it works fine. I'm not too worried. I'm not trying to get super stuck on this or be super scientific. It works fine. That's all I need for the moment. And so yeah, I just cranked the damping up really high, but the problem I actually just realized I had with it, and I finally just got it fixed, was there's actually position drift here. Let's see if I can make it do it. Alright, yeah, it's a little bit harder with this one. Oops. Yeah, this is what I needed it for. This little thing looks like interactive buddy, and his limbs are attached with springs. And if I spin him around like this, it should probably mess up. So yeah, you can kind of see it drifting away, and it just, see his leg is like all crazy now, and now he's actually touching the ground because the spring drifted away from its original position. That is a result of this this code I added here to keep track of multiple twists of rotation, so I could get like a wind-up effect, but that's not really necessary because it introduces the problem of position drift. And so yeah, what I can do for that is just remove all this first, and then what I did was just make a shortest angle too, so when I'm calculating which way it should spring, instead of doing just the basic body B minus body A rotation, you can find the shortest angle to it, and that way you can find which way to spring, which way is the smartest way to spring. And it doesn't have multiple twists, but it works just fine. It doesn't have the problem of position drift. So I think that's all I need to change. So yeah, this works pretty much the same. And I did it over here too, or I'll do it over here too. But yeah, this was the hack I used. I just said like every frame I just checked, did the rotation decrease, and then I checked, did it actually decrease? Like, is the rotation actually going down, or is the rotation positive but it decreased, which would mean it looped around, and like pi plus 1 would be negative pi plus 1, because Godot keeps all rotations between negative pi and pi. And yeah, this is not really needed. I can just do shortest angle too. And yeah, that's all it's needed. Now if I spin it around a bunch of times again, it won't have that problem. Because what was happening before, it was getting the angles wrong and the position was drifting very slightly because of floating point imprecision. So now you see it's not getting all slid down like that. But yeah, this is the spring. I'm gonna put the source code in the description if anyone else wants to use it. It's a really simple class, but I just use it for the I just use it in the plugin, and I have here's a little icon. Where is it? Does it say the name of it? Yeah, so this is I just made this plugin to pretty much do this, so I could just write them all in like this, and it just inherits the pin joint. It's super easy to add a bunch of them, and yeah, this is what I needed it for. This little guy with springy little limbs, coming along pretty well. But yeah, that was a devlog. Thanks for watching. If anyone watched it, and if you need the source code, feel free to use it in the description. I'll just put it in public domain or something. Alright, yeah, thanks.